Very soon. No. He knows you. Great. Problem with this makes the fact that I've lost my hair a lot more visible. Ah. Do you want some of mine? I had yours. I saw a picture. I was so impressed with that. Yeah. Okay, so that's the first talk. This is okay. Are we live? Here. I don't know. I mean, I don't think I mean, maybe. Oh, okay, maybe that computer needs to log in, right? Probably so, yeah. All right. Hello, everyone, and welcome to this afternoon session. I hope you all had a good lunch. I want to say thank you especially to the staff here in Fed Hall. A lot of you are saying that the food is good, and that's nice to hear. So thank you to the Fed Hall staff. So welcome to session 5. This is the session on the special focus of this ICCC, which is on EDI issues, equity, diversity, and inclusivity issues, and also on climate change. And today's session chair is Anna Jordanis from the University of Kent. I will pass it over to her, and she's getting the ceremonial rattle. And it appears we have the obligatory tech thing.
So while we're just getting set up, I'm very happy to be chairing this session, even though I am also speaking in it. So if I go on too long, Dan has permission to just drag me off. But for now, I'm going to hand over the first of 2 talks today by Juliana Shahada, work with Maya Ackerman. And her talk will be on what does genius look like, an analysis of brilliance bias in text-to-image models. So I'll hand over to Juliana.
Hi, everyone. So today I'll be talking to you about what does genius look like, an analysis of brilliance bias in text-to-image models. I'm Juliana, and my research advisor is Dr. Maya Ackerman from Santa Clara University. So the word genius, when you think of genius, who is the first person that comes to your mind? Take a minute and think about that. When we think of genius in general, we think of individuals that have achieved a high level of excellence, whether it be in an innovation, music, artistic world, like Leonardo da Vinci, where he even overlaps art and science. Or you have Bill Gates, you have Albert Einstein, you have Beethoven, Steve Jobs, Steve Wozniak, Alan Turing, and so on. While most people tend to think of genius associated to a man, In reality, what happens is in this world, there are both female and male geniuses. However, society tends to associate genius to the male species. For instance, you have Jane Goodall, a brilliant scientist who worked with chimpanzees. You have Hilary Hahn, a brilliant musician on the violin. You have B.D. Wolf, intersecting art and music. You have Ruth Ginsburg, Katherine Johnson, Shannon Valor, and many more, from Nobel Prize winners to incredible musicians to scientists working with animals to startup founders, innovators overlapping art and music. Across all parts of the world and all types of domains, you have both female and male genius in this world. You have genius across all types of species, regardless of gender associated. And what we want to do in this presentation is bring attention to what's called brilliance bias. So brilliance bias is the implicit association of a higher intellect to men. Now, when does this brilliance bias start? Recent psychological studies have established that at the age of 5, girls and boys tend to associate very smart with both of their genders equally. However, at the age of 6, so 1 year apart, 1 year of a difference, both girls and boys start to think that very smart people are boys. How does this impact the world as people grow up and develop and begin to contribute in society as adults? For example, higher brilliance bias in fields end up leading to fewer female PhD students. You can see on this graph, you have examples of STEM fields and in humanities of lower female PhD student ratios compared to men in math, physics, engineering, philosophy, music composition, and more. Now, how does this relate to technology and specifically computational creativity? So what we took a look at is analyzing how generative models that collaborate with humans to a certain extent, where a human may input a specific prompt, what kind of images they produce in relation to brilliance. Here's an output of Midjourney prompted to create 4 images of a genius person. Clearly distinguishable that 3 of them are male. Why do visuals matter? Why should you even care about this? Visuals play a significant role in the development of your brain and how you think about the world and yourself. You can't be what you can't see. If you look at an image, it's been found in a study that this image puts more ideas into your head in addition to whatever other content you're looking at. So this specific study was based on textbooks and analyzing how images in textbooks affect students' learning trajectory. It's also been found that skewing Google search results change people's choices in selecting if a woman or a man represented a job. On top of that, the volume of access to this kind of exposure further amplifies and affects your perception of the world and how your brain is molded to think about those around you. So there's this cultivation theory which says that repeated exposure changes our perception of the world. And now, currently with where we're at, there are millions of people using text-to-image models like DALL-E, Midjourney, Stable Diffusion, which is a part of what's called a Lensa app. Given the large volume of people using these kinds of models, the effect of images on people and how we start to think about the world and think about ourselves, it's essential to understand the representation and diversity of the content that these models are creating. So in our focus on brilliance bias in the context of binary gender for the initiation of this study, we focused on the question, do text-to-image models exhibit a brilliance bias? To do this, we tested 4 models on the synonyms of genius, brilliant, super smart, and brainiac. And these traits have been selected based on the psychology study that ran tests out in the field, in the world, on people to evaluate the presence of brilliance bias. We took the same 4 keywords. We generated 400 images on each model, 100 per word. Every prompt was phrased as trait, person. And then we compared that to a baseline of just person, 100 images, so that we can compare and contrast what the model creates when it's just given a pure person prompt versus a brilliance associated person as the prompt. We counted the number of images that showed features of men and women based on how the raters distinguish these features in the images, and added another group to capture any images that had both men and women. Some of them had a group of people instead of just one person, or if they did not have clearly distinguishable genders by bias. The results show a clear difference between the number of men and women in the images that are produced. The models generate much more men than women on brilliance prompts. These results are showing us that the content and the images, these artifacts that can be displayed on articles, on web pages, in presentations for classes. If you were to produce something that was about a brilliance topic, about who's a genius, who isn't, these models will end up producing more images of men who are genius related compared to women, whether it be genius, brilliant, super smart, or brainiac. You'll see more individuals who are male in these images compared to women. If you take a look at Midjourney specifically, you see the very strong difference between male to female. Similarly in DALL-E. With Stable Diffusion, we see some improvement. It especially performs better on brilliant. However, the word brilliant has various meanings to it. It can be also associated with words that are related to almost sparkly, glamour, along those lines. Super Smart also had a partially even distribution for Stable Diffusion. These are the results for Cran. However, for Cran, even when you give it a prompt of person, you can see under none, there's a very strong difference between male to female. I'll talk about that in the conclusions. Show you some examples. Here's a genius person from DALL-E. So you'll see an equal proportion throughout here as to the best of my ability of what I can include depending on the model's output of women and men. You can get access to the full data we looked at on the paper. You see here for a genius person that an interesting thing is there's a cloud and a light bulb above the woman's head. On the contrary, the man is thinking with a finger pointed to his chin, or almost like an Albert Einstein look in the bottom right corner. There's potentially this hypothesis we have that maybe the models are trying to add figures around the woman's head as if to potentially say that there is something going on in their brain, to add some symbol significance that they are thinking, they do think. For example, with Stable Diffusion here, you see brilliant person outputs. In these, you have more artsy, colorful, stylistic elements for women compared to men. Super Smart person. I wanted to note there were only 2 images of women, created for this output. You can see that the correlation with Superman is seen in some of the artistic elements added to the images here. And these are some examples of Brainiac person on Midjourney. So Brainiac had connotation to a character called Brainiac. And as a result, that's how you can see some of the green elements, cyber-like additions to the heads of the individuals in these images. So these images were to show you an example of output on the style of the models in relation to the words of genius traits like brilliant, super smart, brainiac, and genius. The conclusions to draw from this study is that text-to-image models strongly exhibit brilliance bias, as you can see by the very sharp contrast between the number of men and women across the 400 images we looked at from each model. Midjourney and DALL-E had the strongest presence of brilliance bias, whereas Stable Diffusion showed the least brilliance bias. It does show brilliance bias, but it shows the least because of the prompts on brilliant and on super smart. And then you have Crayon, which, like I mentioned earlier, is questionable because even when you give it the prompt person by itself, bare, without any brilliance related words, it had a very, very strong difference between the number of men and women that were outputted in the images. So it defaults to male even when it's prompted on a person, basically. It thinks of a person as male. This might be due to a potential bias with studies that demonstrate that sometimes individuals default to thinking that a person, item, object, anything is male, and are biased to not think that maybe like when they think of an animal that it's male, not female, which has even happened to me. I think of animals as I apologize, as male sometimes. And that just shows you that we all have biases in us that we're sometimes not aware of. And studies like these can help us become more mindful of our own ways of thoughts, and also mindful of what we can do to help solve these problems. In future work, we want to look at further studying Crayon's behavior of defaulting to man for a person, and then looking at evaluations across the gender spectrum. So our study was focused on binary female and male in the context of brilliance bias, similar to the psychological studies conducted that focused on binary female male, and evaluating if there is brilliance bias amongst people and what age it starts. Lastly, we want to work on solutions to mitigate brilliance bias. The exposure to this kind of content further amplifies and influences people's mindsets and views of each other, of who they think should be part of a field, who shouldn't be part of a field. And what we want to try and do is advocate for really just be who you are for who you are. There's no gender associated to who you are. So in that regard, genius, if you're a genius, if you're brilliant, if you're super smart, if you're a brainiac, this should also be genderless. How smart you are shouldn't be associated to your gender. How smart you are shouldn't be judged within a few seconds when someone looks at you. And how smart you are shouldn't be further perpetuated in a biased way because of models that are creating massive content and people who are in the millions who are using them. And as a result, further perpetuate such biases across the world. Thank you for your time.
Here we are. I think we're on. Okay, time for a couple of questions.
I have a question from remote.
Michael, go for it.
Thank you. And thank you for a great talk. I was wondering about the skin color of the people. They all seem to be sort of default white, except for the ones that were green, of course. What about, do you think an intersectional analysis would also be interesting in this space? Is there enough data to do, enough image data to do that kind of intersectional analysis?
Absolutely. This is a first study to first initiate discussions on brilliance bias in technology, and the first of a series of studies to look at brilliance bias in technology. We published one last year on text, on language, And the second one is on images. So in future work, part of it will be to expand on what biases we looked at, which is across gender spectrum and also racial context as well.
Thank you. I'm looking forward to it.
Great and important work. It's really a complex situation because I would claim the model isn't biased at all. It's exactly showing what's in the data set. The data set is biased and the data set is humans and humans are biased. So there's this really tricky thing that we assume our computer systems will be some version of utopian, but all they really are doing at the moment is faithfully, in a way, mimicking back what's in there. So there's a real issue of how you kind of clean this data in a way where you don't get this backlog of we're being woke because we're filtering it a particular way. But on the other hand, there's literally tens of millions of young kids using these right now, being affected. This is the future. This is how they will see genius. So how do you deal with this kind of complexity? It's us. We've always been biased. How do we correctly remove it from a data set without being, people coming back after us? We're being too filtering or that kind of battle that goes back and forth.
Yeah, also a really great question. So just a couple of brief notes on that. First off, I'll be talking in a few minutes on another short paper on how we can be actually leveraging these models to instead help combat biases, given that they already have so much data in them that's available. On your earlier note about this is the data itself. Yes, these biases are in the data itself, and this data represents society, given that it comes from society. It's public data as well. It does show that it's mirroring society's biases. Psychologists have established that brilliance bias is out in our world. And it's not that surprising to see certain biases in such models. Specifically, it's the brilliance bias. We should all, even become more aware of it, given that it's a new part of our world that I don't think many people know about even. It's 2015, 2017, that's when they established it in society. And so to understand its presence in data and see how it affects the output of technology is an important step, so we can see what kind of biases data is capturing from the public, from society, and be aware of what kind of content this is generating, so we can put into place solutions and implementations that can help prevent the onset and spread of the bias from continually perpetuating, and maybe even apply it to other biases from what we learned from this study.
Yeah, thank you. Great talk. I was just wondering if you had any intuitions about what was causing the differences between the different systems that you tested it on. So given that they're all fed on biased data, why was Crayon not, having any people that were women, for example?
Mm-hmm. That depends on the model's training and development. So AI models nowadays, they're heavily dependent on large volumes of data, right? So that's one aspect. It depends on the creators and what data they pulled in from the internet. It could be that there's a slight variety in the sources that they extracted this content from. And then the other part is how the neural model is built, from things like how they fine-tuned it, how they trained it to potentially how they fine-tuned it, how long they trained it for, what parameters they set it to. All of that could affect the content that's generated on top of the data that it was given exposure to be learning from. So it's a variety of variables to consider. I don't know the specifics of the data sets they each used or the exact architecture they used, but it would be a combination of both. Yeah.
Right.
Thank you.
Let's thank Juliana again. And I'll ask Janet to come up. Oh, yep. So Janet will be presenting the talk of Create Visions, that's all right, a platform for casual co-creation with purpose, envisioning the future through human AI collaboration with multiple stakeholders.
Great. Thank you so much for having me today. I'm really excited to present this work. First, I'd like to acknowledge my co-authors, a pretty long list here. Most of us are at the Center for Hybrid Intelligence at Aarhus University in Denmark. We also have co-authors from ITU. Sebastian Rizzi is at ITU in Copenhagen, and Neil Maiden is at University of London. And as this is my first in-person at ICCC, I just want to briefly say where I'm coming from. So I'm a postdoc and also the Junior Center Director at the Center for Hybrid Intelligence. And my role is leading the first of our units, so on human skills and competencies. I have a diverse background ranging from computational fluid dynamics to art, like painting and bookmaking, and my PhD is in information communication technology. I also have a background in citizen science, and that is a primary research methodology that I've applied in this work. So, what is this paper? This is the first time I've submitted this type of paper. It's fell under the cultural application paper. And what does that mean? So I'm using a creative software in a cultural setting. And in the paper, we have a description of the system in the given context, an evaluation of experiences from various stakeholders. I was very excited to hear in the previous talks a discussion of the importance of various stakeholders and taking them into consideration. I just want to say it's very important, but it's also very hard and takes a lot of time. But hopefully you can see throughout the presentation that it does in the end pay off. What this paper is not, it's not introducing a new algorithm or cutting edge technology. We have some of that in our other work. Happy to talk to you about it later. Lastly, it does not provide an in-depth description on processual data. So we're not looking at in-depthly on individuals' interactions with the technology. This work aims to address this very lofty goal. And I just read this for you. With the emergence of global societal dilemmas, large-scale public participation in the formulation and implementation of a wide range of local and global solutions is more important than ever. I think we can all agree on that. Yet, in many ways, interest and perceived agency for such participation is waning rather than increasing, posing both a challenge to democracy and the globe. No one important said this. I wrote it in a grant application. I did get the grant though, so that was nice. So this is the motivation for this particular project. And so how do we tackle this? As I listed my numerous interdisciplinary backgrounds, it is an interdisciplinary effort. And so the large team working on this brings together expertise from digital games and gamification, as well as participatory futures, AI for social good, as well as, of course, AI and HCI, and then also from a psychology side and a cognitive science perspective. So this is sort of all brought together into what we're calling casual creators with a purpose. Probably many of you here have heard of casual creators. So that came out of ICCC as well. And with this background, we wanted to create a tool that could empower the public and engage them in conversations about societal issues and create sustained impact. And it's that second part that's really hard. It's much easier to make something that people have fun with and get them engaged if you're an event. But to create sustained impact that actually makes a difference is really, really hard. And we're not there yet, but I do think that we're making good progress on it. So, CreaVisions, AI-assisted participatory futures. We have now undergone 6 iterations of the CreaVisions project running from 2020. And in this paper, we document only the first 4. The last 2 were in 2023 after the paper was submitted. But we have progressed with this tool from a quite simple GAN-based system back in the day when everyone was using GANs towards a system that incorporates both GAN-based, so slider movements, as well as text to image using Stable Diffusion, And finally, in our last iteration, we have adopted only stable diffusion. And we've done this in 5 countries now. Lots of different stakeholders, ranging from conferences to climate summits, to municipalities, botanical gardens, universities. And I'll go through now a little bit on each of these. So with this research, we're trying to investigate the power of these casual creators. So these systems that anyone can use to contribute to a large-scale public use for research questions and societal applications. We ground this research in the concept of community citizen science, and it's a framework which has been used in HCI research to enhance scientific research and community empowerment. As I think most people have an idea about casual creators, but probably not community citizen science. I just put it up here for a moment. It's a framework to closely connect researchers and societal issues by empowering communities to produce scientific knowledge, represent their needs, and address their concerns, and advocate for impact. And so I think what I've tried to do is draw on the vast body of research that is out there in citizen science and public participation in research, and combine that with the new technologies coming out of casual creators. And so in this paper, we outline the different versions as well, and guide that by 4 design goals. So the first design goal is a user-friendly, intuitive interface, because with Crea Visions, we are going out into the general public and running workshops and different types of interventions with students, senior citizens, etc. And the interface really has to be very friendly for these types of quick interactions. So our second design goal is meaningful content and motivation for activities. There's no point in doing this if people aren't motivated to think about problems that they face in their community. Lastly, third, to meet technical requirements. I'll go through some of the technical issues that we've had when developing something that is used at scale and in many different contexts. And lastly, and I think most important and most difficult, is the community buy-in and co-design with multiple stakeholders. So back in 2020, we did the first very basic version of Crea Visions, and we launched it with AI for Good. This was just a very simple interface. We developed it in Unity, it was using StyleGAN, and we prompted participants to imagine what the world looked like 50 years from now, and then to create images of it. Participants had this very simple interaction. They could manipulate style and content of the images, create an image, tag it as utopian or dystopian. We do have a publication on this, but it was specifically focused on the elements of the images that participants identified as utopian or dystopian, not on all of the different stakeholder contributions. So as that was our proof of concept, people were interested in it. They thought it was a cool idea, but it was a very simple interaction. So a little bit later, we paired with the Danish National Climate Summit, Klimafolkemål, and we worked with them to create a new version of Crea Visions specifically tailored for students in Denmark, as well as to be used at an in-person exhibition climate festival. And so we contemplated a lot about how to make this a more a rich experience. So we added possibilities for participants to write titles and captions around their images, as well as to evaluate the type of image on a various sliders, ranging from, is the problem man-made? Is the problem about the future man-made or natural made? Is it something that they think is reversible or irreversible? And then we held an exhibition in the municipality with this. In addition to this, we also had climate leaders in the community create images and use it as their starting point for discussions. So this was quite interesting. We also got good positive feedback on this. However, the downside of it was the images that we were using were still quite generic. So you can see these are mostly landscapes. That is because we were using a landscape GAN. And so in our next iteration, which was last year, in conjunction with the Creativity and Cognition Conference, we trained our own GAN based on crowdsourced images from Venice. So this was our way to try to take this tool that we have created and adapt it much more closely to a local context. And so we had several partners in Venice that helped us with the crowdsourcing of the photographs. And then we trained our system on that. And additionally, you can see here, it looks a little bit different. We were testing out various features that allowed participants to explore the space in a way that was different than just the two different sliders. So here, they could click on images in these 16 blocks that were closer or farther away from their main image. Happy to go into details on that later. We found that some people liked this, but for the general participants, it was too much. So it was a confusing interface to have this possibility of exploring the space through multiple means. And so this highlighted for us the importance of when we're going in and having these one-off interactions with participants, we really need to pay attention to their very specific needs. We had a lot of fun. We worked with senior citizens in Venice as well. It was a cool place to prompt them to imagine what the future of their city could be. I was very nervous before the workshop when I was told the day before that everyone was 65 plus, did not have Wi-Fi in their homes and didn't have cell phones. And I was going in using a casual creator with them, but they liked it. And we got really positive responses about being able to put words and visuals on what they were concerned about for their city. And, you know, Venice is a very controversial city for tourism and climate change. So, in our next iteration, we went to Paris. And I should say the reason why we've done these many iterations is because people have been very excited to try this technology in their community. In Paris, we decided that we were going to try out something new as well. In addition to training our own algorithm, our own GAN, based on, again, crowdsourced images from Paris, we incorporated a next step of including text to image. So in this case, participants went back and forth from using a slider space to using text to image. There are lots of interesting conversations to be had about the affordances of these different types of methodologies. Also have some work specifically addressing those affordances. Happy to talk about that if you want. For the Paris-based work, we also incorporated participatory design. Not sure if anyone has done that before, but we had several focus groups and workshops prior to our main event, which was at the Learning Planet Institute. And in these workshops, we co-designed what types of features, what types of locations we should take photographs of, which places should be represented, and what types of problems the citizens were concerned about and wanted to visually represent. And through this process, we developed our tool, and we also tried something new with the prompting. As before, we had said, okay, imagine the world 50 years from now. And in this case, we asked them to think more concretely about a specific problem and a solution. And I go into that problem solving process in a different work. Again, this is here, the broad overview. So we also did something similar in Aarhus, where we worked with the local community and went to many different schools, which was very interesting to get a perspective from primarily young students, so ages 10 to 17. So they were involved in both the creation of it as well as generating the images. We exhibited at, and we will exhibit at the town hall later this year. And lastly, no images from Belgrade. It was this past weekend, but I just want to say that it was particularly fascinating to be working in this case, in a community that is still rebuilding. So post breakup of Yugoslavia, we wanted to probe them on their traditional means of engaging with the government and then I will just leave it there then, sorry.
Thank you, Janet. Okay, what questions do we have?
Thank you for the talk. Really interesting. I wanted to ask about what you're hoping that participants get out of this. Is this primarily an ideation tool? When you talk about citizen science, we're often talking about getting scientific solutions from the public.
Yeah, so you can broadly break up citizen science into public participation of research. It can be towards specific scientific research questions, as you say, but also involve the citizens in addressing larger societal issues. And so that's the public participation in research aspect. So what we hope the participants get out of it is an increased sense of agency and being able to convey their ideas. And we do this through exhibitions and reports that we have provided as we partnered with the municipality based on the citizens' contributions.
Hello, yeah. Thank you very much. I like a lot this because it reminds me of the thing we've been doing. I think it can reflect what people want in a way and allows to explore that. And my question is, you've been focusing on how these ideation tools, this specific, allows to see what people want in urban area. So, but you've been talking about communities, and I was thinking of more general communities, for example, communities online, or even, for example, research communities, for example, computational creativity community. Do you think one approach
So
like
you said
this
research communities?
research community or computational creativity community, for example, this community, do you think one tool like this could help us identify what are the problems in the area and how we can move forward, like if we can use these ideations?
Yeah, so I definitely think that this concept, it's I call it a casual creator with a purpose, of a casual creator that's well scaffolded to address a particular type of need can be applied in many different contexts. I'm actually starting a fellowship this fall to be looking at how this tool in particular can be used for researchers to convey the impact of their work. For them to identify, so natural science researchers in particular that struggle a lot to convey the impact of their work. So I do think it has a lot of broad applicability to it.
I think we have time for one more question.
Thank you. So really interesting design and projects. So I'm just wondering, if you, and I haven't looked, so you can tell me if I've missed it somehow, but the process of working with different kinds of communities, so children to older people, people with different sort of technical abilities, some of that sort of pedagogical aspects of the work that you're doing, is that, have you published on that or made that those kinds of steps available as well? So sort of the co-design process.
So we have a learning scientist on the team focusing specifically on computational thinking as a learning scientist, and he's guided through us in the process on how to focus on describing the tool and engaging in the workshops. We haven't published on that, as you may see here. Analyze more data is at the top. We have a lot of data from these 6 events, including a discussion on how the work is received. We have think aloud interviews, all of this type of stuff. We just have to decide, okay, what's the most important to publish on versus continuing developing the tool for for audiences, as next we will be in Istanbul.
Okay, so I'll just, so a plug for, I think the process is really interesting and that community interaction is really interesting. So I'd love to see that as a particular kind of model that you are able to sort of get out in some way, maybe as a toolkit or something. Thanks.
Thanks. And can we thank Janet again and invite Sebastian up? Okay, our next speaker is Sebastian Burns, and his talk is going to be entitled Towards Mode Balancing of Generative Models via Diversity Weights.
Yeah, excellent. Thank you. Thanks, everyone. Thanks to the organizers as well for what is my first conference in person after almost 4 years of PhD. This is work that I've done together with Simon Colton, Christian Gockelsberger. Thanks to my co-authors as well for taking me through the process. Generative modeling, a lot of image generation here, mode balancing, and diversity weights is going to come up later again. So let's just jump right into the introduction. To motivate the work and draw some connections to computational creativity and the topic diversity, equity, and inclusion. A little background again on generative machine learning. So usually you want to train a data-driven generator here, so learn some patterns from data and obtain a generator that can produce for us some artifacts of high typicality. That, of course, is only as good, so a model is only as good as a training data, really. So many data biases are easily picked up, and we shouldn't really think about the data as a ground truth anymore. So you might have heard this saying of garbage in, garbage out. And a very important data bias that there is, I think, is data imbalance bias. So the more examples that you have of a certain kind in a data set, the higher the probability under the model and the more likely to be generated with high fidelity, these types of examples. So here for illustration, just cats and dogs. And this, I think, has some significant limitations, both for computational creativity and for DEI. For computational creativity in a sense that data-driven generators, when we use them in our generative systems, they're kind of reproducing what we have in the data distribution. But me as an artist, I'm more interested in the things that are kind of outliers, that are weird artifacts. So I want to generate kind of a diverse range of possibilities. And same for DEI. Underrepresented groups are most often affected by these types of data biases. So in our work, we specifically focus on this data imbalance bias. The way that we approach this conceptually is by mode balancing. So I'm contrasting here two approaches, mode coverage on the left-hand side, and on the right-hand side, our approach, mode balancing. In blue is the data distribution just illustrated, and in red and dashed line, model distribution. Mode coverage tries to exactly match the data distribution, which, as I said before, cannot really be taken as a ground truth. So what we want to move towards is mode balancing, to really kind of equivalate between the different types of examples in a data set. So let's move on to diversity weights, which is our specific implementation to this kind of conceptual approach. It consists in two parts, really quite straightforward. So on the one hand side, weight optimization. So we derive an important weight for all of the training examples in a data set. And then we use this weights in a training of our model. So just an important sampling scheme. So you can train your model as usual. So no modification to the training objectives are necessary. You just sample the training examples according to the weight. So of course, the most important bit is how do you develop the weights? You make use of a diversity measure that came out, I think, in October, November 2022, called the Venn score. It takes a similarity matrix of pairwise distances between artifacts, as well as a probability vector of all the artifacts. And I think we've heard this in other talks as well, perplexity, so exponential entropy, really is kind of a description of the chaoticness of the system. I think it comes a little bit from like von Neumann entropy. Essentially, it measures how well a probability model can predict a sample. And if there's more diversity in the sample, it's more difficult to predict, and therefore the score is going to be higher. That's what we like to achieve. We make use of this diversity measure, and we formulate basically a optimization problem. So if we have a matrix of similarities between all the artifacts, what are the optimal weights for this set of artifacts that optimizes our diversity? The way that we try to then approach this computationally is basically through gradient descent. We have a loss function with two losses. On the left-hand side, diversity loss that just simply maximizes the diversity score. And on the right-hand side, an entropy loss that acts as a regulator. If we only do this with a diversity loss, we can have very extreme weights. So on the less important examples, they are going to be very, very low, and then the outliers are going to have very big weights, and that's going to be a little bit more problematic in our important sampling. So we want to regularize that and try to penalize the non-uniform distributions. So the way that we have to approach this then is basically balancing between the two losses, the diversity loss and the entropy loss. And this introduces a hyperparameter, gamma in this case, which just controls the balance between the two. So this is another value that you have to optimize. What we are going for here conceptually is we want to converge to a stable distribution of weights, while at the same time maximizing the kind of diversity in the Venn score. So part 3 is a very small kind of study of how you could do this in practice with MNIST, a very common machine learning data set. Just a real simple proof of concept study. So we selected a subset of the MNIST data set, just digit pairs. What we wanted to do is pair digits that are dissimilar, like 0 and 1, and others that are very similar and might be a little bit more difficult to model together, 3 and 8 and 4 and 9. For all of these pairs, we select from either digit 3,000 random examples. So this composes a balanced data set of 6,000 examples in total. And we do this 5 times for all the different pairs, and then we run 5 times different models. So all of the results that you see here are kind of means over the several different runs. We then take the images, pass them through CLIP, get the embeddings, and on this we can compute the pairwise similarity matrix, which we use for our Venn score. So we fine-tune the hyperparameter for these digit pair data sets. The optimal value in our case was 0.8. And this is an example here, what kind of examples you find that are then high weighted and low weighted. So on the bottom row, the typical examples of 9s and 4s that I've seen many times, but I had no idea that there were these weird examples in the data set that are kind of almost smudged. It's not really clear if this is like a 4 or a 9 or, so I was very happy to see that this kind of picked up exactly what I wanted to do. So we compare in our study 4 different models as a baseline model, just a standard GAN, and then 3 diversity weighted GANs with our optimal parameter number 3, and then the highest parameter that there is 1.0. That just means that we don't take into account the entropy loss at all. So it just focuses on the diversity, and it reaches this case where the weights are very extreme and kind of polarized. And then one which is just a little bit in the middle, the number 2 of 0.6. All the models have the same architecture, same hyperparameter, so quite a fair comparison. We then evaluate the models on these different measures. So for the sample diversity Venn score again, Then the typical kind of standard evaluation metrics on sample fidelity and mode coverage. We did test the inception score. I'm not going to show it here because it's not super relevant, but FID and precision and recall. We did, however, make an adjustment to threshold inception distance because what happens when you introduce a weighting scheme over different training examples, you kind of modify the target distribution. So where standard FID uses mean and covariance of a large set of samples, we have to now instead use a weighted mean and a weighted sample covariance as the adaptive statistics. So these are the plot for results. We compare all the three different models here. I need to slide this out of the way. On the x-axis, you have the 4 models. On the y-axis, you have the Venn score here. So these are the results for the 3 digit pairs for standard model. Our model with 0.6, 0.8, 1.0. So the tendency is quite clear that the Venn score, the diversity increases somewhat. It does, however, come with a caveat that is loss in typicality. So you can see that in the precision here, where still higher value is better, and the tendency goes down. The same for recall. And then if we look at FID, quite similar here. The y-axis is inverse, so lower value is better. So although it goes up, it's actually worse. But if we look at our adjusted weighted FID measure, actually our models perform much better in modeling the new weighted target distribution than the standard model, which was not unexpected. So to wrap this up, conclusions, brief summary of the contributions here. So mode balancing is more the kind of conceptual idea behind the work. So we want to abandon the idea of the data distribution as a ground truth because it's just susceptible to too many data biases. We also want to consider diversity as part of the modeling objective, really, and the idea is to cover all of the data modes with equal likelihood. Algorithmically, we approach this with diversity weights. So our approach is to mode balancing is that diversity weight scheming. And this is just a method to increase the model output diversity. It is model agnostic. So we worked with GANs, but you could technically use it with any other modeling scheme. That's one of the big to-dos that we still want to work on, especially in diffusion modeling. That's it's now the most prevailing method, I think. I want to mention also, talk a little bit more about this diversity typicality trade-off, which is one of the big things that came out of this. So you actually, with a hyperparameter gamma, that you can actually control this trade-off between the sample typicality and diversity. So a little illustration here on the right-hand side. In blue, we can put almost an emphasis on uniform weights. You will have higher typicality. It's kind of the standard GAN training, definitely the standard diversity as well that you can expect. But if you want to go all in on the diversity and kind of put an emphasis on the Venn score, you will have higher diversity, but at the cost of lower typicality. So our implementation is now available. I uploaded this earlier, so you can test it out yourself. What is available is mostly the optimization for the weight vectors. I don't have the code available for the experience, but if you want, you can, of course, reach out to me and let me know. And I'm going to leave you at the final slide some non-cherry-picked results. Thank you.
Thank you, Sebastian. Perfectly timed. I'm going to go over here first. Right. Yeah.
Really great talk. I really found this really interesting. I'm curious to know if you tried any just like the normal undersampling, oversampling of the data set and compared your model to just classical methods of just trying to balance the data set like that.
We did not. So this would be kind of the standard machine learning approach, right? the question would be, how do you know what to oversample? So I guess from the standard machine learning approach, you have classes, right? If you have a binary classifier, you know, true and false. Maybe you have 60% true, 40% false. It's quite clear if there are classes involved. In this case, generative modeling's not supervised data sets. It's a little bit more difficult to figure out which sample exactly to oversample or do a different weighting. So this is exactly what the diversity weight is about, kind of, because in the images, features appear in different images to an extent or less, and I wouldn't really know where to start to balance this out. So this is what the diversity weights is about. I think oversampling is maybe good different approach, which could work in a similar way with the same approach. Yeah.
Thank you so much.
I had a question about the entropy loss. So entropy loss, you train it in order to converge, but you mentioned something about adding a penalty to it. So is the diversity part how you add the penalty to it? Could you add some content information about that?
Sure.
Thanks.
So the entropy loss is the penalty. So because if you just let diversity do its course, I mean, it's gradient descent, so it's going to try to wiggle out just the 0.0001 kind of maximum score. And in order to do that, it has to like go for the most important samples, very big values, for the less important values, very small ones. So the entropy loss, entropy is maximized where for a uniform distribution, which means just every type of sample is weighted the same, right? So these two act a little bit against each other. So entropy loss wants all of the weights to be the same, and diversity loss wants to be wants the weights for the most important samples, so the rare ones higher, and for less important samples to be lower. So entropy loss is the regularization here in this case, and that's why we want to also balance it to. No, so this is the loss for the optimization only of the weights, and this is a separate process that you do offline before you even start the training. This is specific to every data set that you have. So basically, you gather your data set, you run, you derive your weights with this approach. You have to figure out a little bit what is best hyperparameter here, with a little bit with the idea that I gave you. But then you can use them for any type of learning algorithm, really. And the weights won't change unless you take out or put into new examples.
Yeah, thanks for the talk. The examples that you were sort of pointing to from the original data set, which were the weird ones, that looks a lot like the samples that get identified by a lot of explainable AI approaches, like data shapely. Have you looked at if there's any overlap?
Okay, I don't know. Can you explain a little bit what I'm not aware with the explainable AI.
I don't know if I have time to explain explainable AI.
No. How does this? So you have seen this type of examples?
Yeah.
Okay.
Let's talk in the coffee break.
All right. Okay. Great.
Yeah, that sounds like a coffee break question.
Perfect. Thank you.
But I think that's great. Thank you, Sebastian. Thank you, Megan. And Vanessa, I think is our next speaker. Yeah. So Vanessa Utz is our next speaker. And Vanessa's talk is titled Climate Implications of Diffusion-Based Generative Visual AI Systems and Their Mass Adoption.
Does this work? Yeah, okay. Hello, I'm Vanessa. I'm at Simon Fraser University in Vancouver, more specifically their School of Interactive Arts and Technology. And today I'm going to be talking about our work on generative AI systems, their mass adoption over the last year, and the associated climate impact. So to get started, I want to show you guys this graph. So this shows the amount of months it took these individual platforms to reach 100 million users. Now we have Instagram on top, which is a very popular social media platform. So popular, it was acquired by Meta a couple years ago. It took them 30 months, which is 2.5 years to reach 100 million users. TikTok, which took over the world by storm 2 years ago, it took them 9 months to attract 100 million users. ChatGPT, on the other hand, it took them less than 2 months to attract 100 million users. So clearly there's something about generative AI that is very appealing, and the masses were ready to adopt these systems into their lives. Now, the last time, let me just move this for a little bit. The last time we saw a digital technology go through such a boom was actually not too long ago. It was 2021, 2022, when we had the blockchain technology and everything associated with it. NFTs, cryptocurrencies go through this boom. Now, as the numbers of users increase, the discourse in the public changed a little bit to include a discussion around the sustainability of these systems because they're so computationally demanding. Now we have generative AI, and we haven't seen that discussion yet. There is work being done at the moment looking at the energy consumption and the carbon emissions associated with training large machine learning models. But so far, nobody has really looked at the mass adoption of these systems and the users using them at such a large scale. So the purpose of our research is really just to get the conversation started, get the ball rolling, and include a large amount of people in this discussion. And to get this conversation going, we provided some initial estimates into the energy consumption of these systems. And we also wanted to look a little bit into the motivation, or why all these images are generated at the moment. So let's get started by looking into the energy consumption, which is basically the meat of this conversation. Now, as we stepped into this area of research, we might have been a little bit naive in the beginning, thinking there would be a lot of data available at this point. We're talking about corporations, and they do not like to share their data. So we had to search far and wide to get some data points. Now, this is basically a summary of the data that we got. You can see there are still a lot of unknowns. For example, we did get some somewhat unreliable data on how many images might be created for Midjourney every day. But since we couldn't really verify the data, we just decided to ignore it for now. So a couple of data points that I do want to point out is, for example, Midjourney. We are, see this? Yeah. So we have 10 million users. That is only the members on the public Discord server. Obviously, you can add the Midjourney bot to private servers. We have no idea what is happening on these servers. I also want to point out the 10 million users for Stable Diffusion. That was our most reliable data point. We got that from an interview with the Stability AI CEO, who was explicitly talking about 10 million daily active users. That is not an estimation based on downloads. This is actually a number on how many people are using the system every day. So this is what we wanted to focus on in the beginning for our most conservative estimation. So we used the 10 million users that are using Stable Diffusion every day. And then we still had to make some assumptions based on the hardware that they might be using on there to run these systems locally, as well as the duration of use. Now, we didn't just pull this from somewhere. We had some reasoning for these assumptions. So for the hardware, for our calculations, we were assuming that the users are using RTX 3090. Now, that might be overkill. We understand. But our reasoning was, first of all, it was a thing of convenience. We have an RTX 3090 in the lab. We could confirm a couple of other assumptions. Also, the RTX 3090 does outperform other GPUs on benchmark testing with Stable Diffusion, as well as apparently, which we didn't know, Stable Diffusion only natively supported the RTX series initially when it was first released. So we were assuming that maybe at least the first adopters of these systems might have used this type of GPU. Obviously, ideally, to get a better calculation, we would actually need to know the exact hardware that people are using, but for an initial estimate, this is what we're using. If we're dealing with people who are using less powerful GPUs, yes, the peak energy draw would be lower, but then it would run for a longer period of time. So this is just for an initial estimation. For the duration of use, we actually conducted a little survey. We had users estimate how long they're using these systems for. We had them estimate how many images they create per week. Now, 2,000 images seems really high. We were surprised by that too. I can tell you that we have since conducted a second study with a very similar weekly average. So at least the active users within AI art communities, or when you're dealing with students as participants who are at a tech and art school, they're generating a lot of imagery. So we're working with the 2,000 images per week, around 285 images per day, and then using that GPU, a proper image size, we get to around 20 seconds per image, which leads to about an hour and a half of peak energy draw per day. Now, we then plug that into our yearly energy consumption calculation, first per user, then for 10 million users, and then yearly, which leads to a total, again, it's our most conservative estimate for now, a peak or like a total annual energy consumption of 1.92 terawatt hours, which on its own might not mean much. According to the United States Energy Information Administration, that is equivalent of the total energy consumption of the nation of Mauritania in Africa. So that is our most conservative estimate, just looking at 10 million people running Stable Diffusion. We then extrapolated it to other systems. Again, we wish we would have more data because, for example, Midjourney, it's cloud-based system. People are not running it on their home computers. But for the sake of this initial calculation, we're just assuming that the 48.5 million users who seem to be using generative AI art systems at the moment are running something like this on their own computers. Again, we need more data, which we don't have at the moment. We put that into our energy calculation and we get to a yearly energy consumption of 9.29 terawatt hours, which again, at the higher estimate, is now equivalent to the annual energy consumption of Kenya. So once we had these initial estimates, which seemed incredibly high, we just wanted to look into it. We didn't expect the numbers to be that high. We wanted to know, why are all these images being generated? So again, we had our own survey. We also relied on some Midjourney polling. Midjourney is really good when it comes to reaching out to their own users and seeing like what they do. So we have our own survey of 92 people, and then we had Midjourney polls of varying sizes. So first we wanted to look at the main motivation. Why are people creating this imagery? Now in our data set, 38% of participants said it's just for themselves. They don't even have the intention of ever sharing their imagery online, which was surprisingly high considering that we're talking about AI art communities where the purpose is to share your work. So we had a lot of lurkers in our data set. And then the Midjourney poll, which was shocking, was that 98% of people said we're just generating it for fun, for our own entertainment. There's no, which it has inherent value, but the images are not created to be shared or for professional practice. And then we also wanted to see like, what is the distribution of everyday users and professional users. And in our data set, around 14% of people said they're actually trying to integrate these generative AI art models into their creative practice or any type of professional practice for that matter. In the Midjourney poll, it was a little bit better. 35% of users said, no, we're trying to integrate this into our professional practice. Now, we do want to say
that we think that this proportion is probably going to shift. There's a lot of talk happening right now about integrating generative AI into workflows in workplaces. So the number of professional users is most likely going to increase. So what now? We know it's mostly private individuals creating a lot of imagery, and there is a climate impact. Now, first of all, before we can really continue, we need to advocate for more transparency. Once we started trying to calculate the climate impact, I mean, we realized that there was a lot of assumptions, educated guesses that we had to make. We couldn't really get really good estimates. So we need more data on how many daily active users there are, what the image output is, what kind of hardware they're using. When we're talking about cloud-based services, where are their data centers? Because even the location has an impact on the type of climate impact associated with the energy consumption. And then we know that across the ICT sector, whenever a third party, which is us, is trying to estimate the carbon footprint, carbon emissions, or the energy consumption of these systems, it's usually significantly underreported. So this is just a big caveat. So future work, and a lot of that are things that we're currently working on already, is really trying to understand what attracts all these people to these systems. Now, we're already trying to link it or study it using the uses and gratification framework, which has already been applied to study why TikTok is apparently really attractive to a lot of people. So we're trying to work in that direction as well. We also want to understand more who these users are, especially when we're talking about a new technology. And in our data set, when we're starting to look to recruit people into these studies, we noticed that a lot of people, at least in these communities and on Midjourney, are European or North American. And now we're introducing a new technology which has a climate impact. So we are really concerned about the global North, the global South, accessibility, and representation. So we want to look into that a little bit more too. And then the goal is to find solutions collaboratively. So as a community, like, we are not saying don't use these systems, right? We're just trying to get the conversation started, include other researchers, include the users in finding a possible solution. This is something that we've actually just done, just promoting future work that's about to be published. We just did a study where we used this data as well as data from other scientists in this area on the learning and the training side of these models, and presented it to these users. And we wanted to get feedback on their thoughts to this data. And then we need more attention. We need more eyes on this issue, because generative AI is moving fast. And it's really good. We've seen a bunch of conferences just in this year looking at generative AI or AI in general and climate change. So that's really great. But we need more researchers to think about the climate impact of their work. And I'm just going to leave you with this screenshot that I took yesterday. So when we wrote this paper 4 months ago, in our data set, we said that there are 12 million confirmed users of Midjourney. Now, when I took the screenshot yesterday, they're about to reach 18 million users in just 4 months. So I'm just going to leave it at that. And thank you for your time.
Hey, great talk. It was great, seeing all these numbers and how you got to them and stuff like that. And I'm wondering, would you happen to know of any research or comparisons on how this energy consumption compares to more traditional computationally intensive tasks? I'm thinking 3D rendering, like Blender. How does this AI generation compare to that, which is also heavy GPU intensive?
So we haven't looked at that specifically. We did in the paper compare it to NFTs and how computational heavy they were. Now, NFTs required a lot more energy than the image generation. What we do need to think about is, well, obviously NFTs seemed to be a bubble, and the bubble has burst. But these systems, they're actually useful. And there's so much talk already about integrating them. Again, Adobe is interested, right? So it's more about on the small scale, on the individual scale, it's less impactful. But as soon as we're moving into this like mass adoptions of these systems, then we're seeing a massive impact. On a similar note, so I mentioned the other study that we already did, where we provided this data to users and we wanted to hear their feedback. And we actually had one user say, well, what about video games? If I'm not using Midjourney, I'm playing video games. Or what about, planes that are flying? And I like to think about it the same way we think about light bulbs, right? We stop telling people to turn off the lights to save energy. Instead, we came up with a more energy efficient light bulb. So in a similar way, like, again, we're all researchers, we're creating algorithms, we're creating the hardware. So all of us need to just think about it and think about a solution.
All right, awesome. Thank you.
Hi, thanks for the talk. Yeah, so like I'm actually, when you're actually talking about NFTs, I was actually thinking about since like Uber a few years ago, and they heavily basically stipended all the trips and made them super, super cheap. And then the bubble, exploded and everything became its original price. And if you think about what we are looking at now, you can use Bing with GPT-4, quote for free, unquote. And you know that it comes with a very high API tag price, and ChatGPT is also quote free, unquote. But of course, if you call it API, or you go off its limit, you need to pay a lot. I'm actually wondering, how do you think about this stipending? How much do you think the availability of these models and their affordability comes from people just fighting for the market? And while we go into a situation, for example, a year later, suddenly no one is going to stipend your API usage and people just go back to this problem more seriously.
That's actually a really good question. So honestly, I haven't thought about that. But I would say that the reason why a lot of these systems are cheap is in order to get that market share, to get these users. And the idea is then once they increase the prices, you're already gonna be used to using these systems on a regular basis. So while I think, some people might stop using them, and I'm probably sure that the rate of adoption will, level out at some point. It's not going to keep on rising like the way we're seeing it right now. But I don't think we're going to see a substantial decrease in the use of these systems. But this is just me speculating. You're welcome.
Let's take one more question. And if Petra could go up and get ready for the talk.
Yes, thank you for the talk. I think the number of personal users was surprising. So do you have any insight in what are the reasons for the use? For example, are they practicing the use of these systems, or is it for entertainment, etc.?
Yeah, so that was just a very short summary, obviously. We have a lot more data on that. So we saw a lot of people saying they don't share it. We also saw a lot of people who, for example, there was one user. Well, one of the reasons why the weekly average is actually that high at 2,000 images per week is because we have a lot of users who generate tens of thousands of images per week. And a lot of them seem to be professional, or at least somewhat professional users who we had these longer interview style questions with them where they could elaborate on their practice with these systems. And they were saying that they would iterate on an idea over 500 times to get that perfect output, and then they would sell it. So there are people who are using these systems at a large scale because they're selling them. We also had one participant specifically saying that he was on disability, he couldn't work. So this has become his life. Like, this is almost like an art therapy for him. So it is a lot of different uses, a lot of different reasons why people use these systems. Does that answer your question? Yeah.
All right. Thank you very much.
Thank you.
So we're just resolving now. I think that we're going now into the short papers. If anyone is about to speak and was not expecting to be a short paper, tell me, please. But first of all, so welcome Petra Jaskalainen to the stage. And Petra's talk is how to make AI artists feel guilty in a good way. Designing integrated sustainability reflection tools, SRTs, for visual generative AI. Petra?
Is this working? Hi, my name is Petra Jaskalainen, and I'm from KTH in Sweden. I'm a PhD student in sustainability and environmental ethics of creative AI and AI arts. So I'm presenting today our short paper, How to Make AI Artists Feel Guilty in a Good Way, Designing Integrated Sustainability Reflection Tools, SRTs for Visual Generative AI. So the work presented in this paper is primarily done by master students who I have been supervising last spring and autumn. Unfortunately, they were not able to be here, so I'm presenting this paper on their behalf. So AI can be very energy intensive, and artists are currently lacking access to this information. With the growing concerns of climate change and calls for environmental sustainability, there is a need to explore strategies for communicating sustainability information to artists who are using generative AI. Most of the existing tools, carbon energy consumption trackers, are general domain. They are calculating the impact based on GPUs, and also they require technical competence that artists may lack. Such as installing energy tracking software or just understanding where the computational expenses take place, which might be difficult for people from non-technical backgrounds. And we take a critical disposition in this paper, so we cannot assume that just providing information will result in pro-environmental behavior or increased sustainability. Prior sustainability research, in contrast, has indicated that it's very complex. It's more complex than that. By highlighting emotional and social dimensions of sustainability. Acknowledging the complexity of change towards sustainability, we should regardless investigate strategies of communicating sustainability information to artists to understand when and how these design strategies could be used. So because of that, our aim in this study is not to change behavior, but it's to explore the design space of communicating sustainability related information. And lastly, while there can be many definitions on sustainability, planetary boundaries, computing within limits, not exceeding the needs of the future generations in present time, in this paper, we specifically focus on materiality and within materiality to energy consumption, following the framework that I proposed last year on this paper that is down here. For the sake of convenience, in this paper, we use acronyms VGAI for Visual Generative AI Systems, and then we introduce the acronym of SRT for Sustainability Reflection Tools. We used a research through design as an approach, which included design informing survey, design prototyping, and user testing. The purpose of this study was to explore the design space of integrating sustainability reflection features into VGAI system. And we provide preliminary knowledge of the design characteristics that can be leveraged, as well as artist experience of them, while opening up directions for future studies. So this is the SRT prototype that was tested with the participants. So essentially, these sustainability informational design elements were embedded to a traditional VGAI interface design, where the user can write prompt and choose settings for the generation. And the colors and the graphs and the symbol of a leaf were used in design. They were defined based on the design informing survey that was done in the first stage of the process. You can access the full prototype through the QR code if you want to see it. So when we looked at the results of the prototype user tests and also the surveys, these things stood out. The color and the data visualization were perceived more important than the pictograms in conveying sustainability-related information. For data visualization, it's probably quite obvious because it has most informational content, and colors, they might be preferred as they are more intuitive than the pictogram symbols. For the data representation, granularity of representation was preferred regardless of which visualization format. We had pie charts, bar charts, and line charts that we were showing them. Then the information represented should be relatable. In showing graphs or visualizations, the artists need to be able to relate to that, to other activities or mediums of their practice or their daily life. And it would be a further domain of inquiry to investigate which relations have the most meaning to the artists and why. Artists indicated feeling uncomfortable or negative emotions when being faced with the energy consumption information of their practice, but rationally processed these feelings and noted how they were willing to be evaluated or judged by the system in terms of sustainability because they knew it was for a good cause. So interestingly, here they brought into the discussion their values and how that relates to pro-sustainability behavior. So indicating artists who perceive sustainability as important or a good cause seem to be more receptive towards the SRT systems. And finally, the artists saw a use case for such a system, indicating that they could likely utilize the low energy settings for the exploratory phases of the creative work and increase the consumption fidelity when advancing to the later stages. So just to conclude and discuss, there are many challenges that relate to sustainability in general and SRTs. So firstly, it's the long-term behavior change for sustainability. So even if we provide such information or low energy settings for their practice, does this contribute to long-term behavior change for sustainability? And under which conditions could they contribute? And what is the role of the ICT systems in facilitating such behavior change in comparison to other methods, for example, methods that are not using technology at all? So I think in this way, we need to also question the use of technology fundamentally. One of the problems is that when we try to fine-tune the systems and to make them more energy efficient and to provide sustainability related information, we are building new layers to the technology, and that can in turn create a new environmental cost. So that is what has basically led into this situation as well, where we are right now in terms of sustainability. And that brings us to the second problem of how to align with sustainability. So especially when we take into account concepts from ICT and sustainability, such as rebound effect, if we design more energy efficient technologies, the total consumption can increase and still become higher in the end, as was discussed in the last presentation. It's quite likely that accounting for energy consumption or providing information of it is not enough. So we need to address in the future these questions. How can we stay within the planetary resource boundaries? What chunk of those resources is VGAI justified to take in comparison to everything else that we have? And then we need to look into emotional, affective, and other aspects that explain the artist's relationality to the world and materiality in order to understand their consumption, or in other words, their interaction or relation with material. Yeah, thank you.
Thank you very much. Okay. I'm afraid we don't have time for questions. You have to catch Petra at the break. I'll invite Juliana to come up next, but can we give Petra another round of applause? Juliana? Okay, our next speaker, so this is in the short papers. So each speaker has 5 minutes plus 2 minutes for questions. Our next speaker is Juliana Shahada, who we saw earlier, with her second paper of the session, Shattering Bias, a path to bridging the gender divide with creative machines. Juliana.
Hi again. In this paper, I'll be talking about shattering biases. So how can we use creative machines to combat bias? Quick overview, summary. Like I mentioned earlier, popular creative machines are perpetuating gender biases. These vary across different forms. You have occupational, brilliance, and personality. So in occupational, you have examples of, for instance, a nurse being thought to be a woman instead of a man more often, and doctors being thought of to be a man instead of a woman more often. For brilliance bias, that's what I introduced earlier. And this associates both in language and in images. We've established that in text, you see brilliance bias, such as associating words like innovative and creating and acing and winning to men more often than women within the top 30 words. And in images, we just saw that when you give it brilliance prompts, you often see more men than women in the images. Personality bias, that associates things like smiling more often to images of women. The question here is, can we create creative machines that help foster gender equity? And in this presentation, I'm laying out a roadmap of a direction of research we can explore to do this. So direction one is to help women realize their potential. Through creative systems, we can help a young woman step into a personalized experience where there isn't a bias against her. And in doing so, help themselves through stories, arts, or songs to see what they could look like in non-stereotypical roles and to explore themselves within boundaries that are limitless. The second direction is to help women cope with gender discrimination. So through creative systems, we could create environments where women can process their experience of discrimination. And this could help women overcome resulting negative effects through a therapeutic computational creativity side, which is a new emerging field in CC. And then a third direction is fostering empathy. So how could we create CC systems that allow people to tap into their empathy and understand the views of what women might be encountering? The goal here is for the world to see what women are seeing. For example, imagine stepping into a world where you're one of few men in AI. What would that feel like for you? What would that look like? What would the experience cause you to think of? Would you feel secluded? Would you feel included? Would you feel nervous? Would you be anxious? So through these experiences, we hope to flip the world in a way and let people see what women are seeing. To conclude with this direction of research that we're proposing, we hope to create safe, engaging, creative environments through CC systems that can help bridge gender gaps instead of further perpetuating them. This can be through creating experiences for women to explore their potential, seeing themselves in various roles that society otherwise might bias isn't really typical for a girl or young woman to pursue. Expressing women's struggles and seeing the world from women's views. Given that these large models we're seeing today have so much data for language and for images, what we can do here is help shape them and guide them toward content that could instead be helping connect people together and creating bridges rather than divisions. We hope to also adapt this method of research we're proposing across the gender spectrum and across other discriminatory biases so that we can apply what we learn through these methods we implement and test to see how else we can use them to help overcome other biases in the world. Thank you for your time.
Thank you, Juliana. Okay, and time for one question.
Thank you. I think it's a really cool idea. I was wondering about how using these image generators, even though you're trying to fight bias, might end up reinforcing some biases. And all the images, all the women are thin, have long hair, are wearing makeup, or able-bodied. Can you speak to that at all?
Yeah, so it depends on how you use the system, right? A lot of it comes down to human responsibility and critically thinking about how to collaborate with the system. And instead of letting it be what you could say more organic in kinds of inputs, you could creatively guide it toward creating content that's actually more diverse and representative. There are some initial tests we've run that demonstrate you can create content in certain directions that you would like to see. So it's really a matter of how you're interacting with the system to help it produce what you have in mind, rather than having it do more work than it should be doing, if that makes sense.
All right, and can we thank Juliana again? And now we hand over to the next speaker, which is me. Um, so Dan has the power and Joao will have the mic. Okay, this is a co-authored paper between myself and Marzia Balwani, who you also heard from earlier. Marzia and I come from very different associations with ICCC. I have been involved in the conference for over a decade. I helped organize it in 2017 and 2018. I was the co-chair, the program co-chair. Marzia is involved in the conference for the first time this year. What we both share are reasons why, related to diversity, equity, and inclusion, we have not been able to attend the conference in 1 year. So we performed an analysis of the ICCC proceedings over the last 6 years. And we come out with a bunch of recommendations, suggestions. This is specifically focused on ICCC. Okay, so I'm going to not make comments here that we can make across multiple conferences, academic conferences in general. This is specifically for ICCC. So looking back at the last 6 years of conferences, what do the paper contents show us in terms of a diversity analysis? So Loughran and O'Neill back in 2016 found that the top areas that we're publishing in, if I exclude the other category, are NLP, music, and images. And we also found those three to be the top areas in our analysis the period later. They're all Western, nearly all Western styles. Okay, with them, I generalized there with something like jazz, for example. So many of them are in the English language, the songs that our systems are generating, the poetry, the texts. And at the moment, we're dealing with a situation here where we all may be left behind. How many of us are going to have the resources to keep up with developments in AI at the moment? So are we being inclusive in our ways of accessing the content that we would like to publish in this conference? Or are we facing the problem where many of us actually will not be able to publish anymore because we can't keep up with the work? Tegelius and Yannakakis have published quite an interesting paper on this, which we reference in the paper. And this comment on diversity in data sets comes up. We echo that. We did a gender analysis of authors. This is flawed. We assumed binary, and we did this based on assumptions and guesses. We found a very clear male presence in ICCC, follows previous findings. We did not see that kind of issue in the keynote speakers for ICCC. ICCC is very good at encouraging gender diversity across the spectrum. But we could certainly do better with role models for the doctoral consortium, things like that. There are various reasons why, for example, I wasn't able to be a mentor this year to do with sports day for my daughter. A reason that we wouldn't necessarily have, right, if I was in a different situation. We looked at the dates for ICCC, the timelines. Typically, our deadlines for papers are in March and May, and conference dates tend to be in June. There's a lot of dates that clash with that are culturally important. My co-author for this paper, Marzia, was in Ramadan for the majority of our writing the paper, and we had to reschedule the final write-up because she was celebrating Eid at the end. I think the timeline is something that the organizers this year have found problematic as well. When we look at the effect of going online during lockdown, you can see this shoot up in European authors, which is replicated over here in the number of papers and the number of authors in the online years. We should note that 2020 people submitted as if it was going to be happening online, in person, then it happened online. There is what I'd like to call, I'm looking at Kaz here, the Kaz Grace effect for Australia, this clustering. And just to reflect on my final point here, I want to give a little shout out. I don't think Raphael's here, but this idea of English being the primary language that we communicate in. We've had multilingual sessions at this conference before, but only once. We have one publication that's in Spanish on computational creativity, which we don't cite. Maybe we should. So maybe the language aspects of this are useful to look at as well. So because I've been told off by the chair already, I'll stop being a naughty chair myself and leave my recommendations up there and open it up to questions.
So any questions?
Pablo,
Just to answer to two of those, doctoral consortium, we did contact a lot of people, and in the end, what we got was not because of what we wanted, but only because they agreed, and there were a lot of other people that couldn't for various reasons.
Yeah.
So,
and this, I think that's the point I was getting at, actually. It wasn't the ability to ask people, because I know that you asked a lot of people. It was the fact that many of us simply couldn't get here early enough to be present for the doctoral consortium because of things like family requirements. And yeah, so I absolutely did not mean that to be.
And on the Spanish issue, we only recently discovered that I come from Spain. I've had a research group on computational creativity for 23 years now. And we've always had our webpage in English because we thought more people would read it. And we only very recently discovered that if you write creatividad computacional, which is computational creativity in Spanish in Google, we don't show up at all. And we were a little concerned, but you have to find a balance between these two things, being inclusive and being read.
Yeah, and this is across all academic areas, isn't it? That we have this problem with the bilingual side of things and multilingual side of things.
Thank you for this. It's such an important area. I ran over to another part of Waterloo in their lab, and they just got a flight simulator because there's not enough pilots in Canada. And one of the things they realize is they need to redo how a pilot is with women in mind to bring that through. And so it's happening, and we just have to keep it happening. The other odd thing I'd like to bring to the table, although I already forgot it, is right now there's 21 women in this room and 26 guys, and a lot of us go to these conferences. That's amazing, you know, and a really good number. So we just have to keep doing it.
Yeah,
no question.
Exactly. Let's look at the country breakdown of us though, and we're in Canada now. So we're in the area where our North American line should be quite high. I don't think we have that yet. Maybe we do. It's hard for me to guess. Anyway, I think I should probably hand over to the next speaker. Yeah. So can I ask Kathleen Fraser to come up? Hi, Kathleen. Okay. Oh. I'll let Joao do the technical side of things. So Kathleen's going to be our next speaker. Kathleen Fraser's presenting the paper, Diversity is Not a One-Way Street, Pilot Study on Ethical Interventions for Racial Bias in Text-to-Image Systems.
Let's see. Is this good? Okay. Thank you so much. Before I start, I just want to mention that this is work that I did with my colleagues, Svetlana and Isar at the National Research Council of Canada. So our motivation for this, I think, has been really well described by previous speakers, but these text-to-image systems have become super popular with the general public. People are using them to create artwork, to create sort of stock photography, to create illustrations for articles, for websites, and so on. But we know that these models can demonstrate, and in some cases even amplify, existing social biases. So in this paper, we really focused on racial bias, and we think of it in two different ways. First of all, the underrepresentation of dark-skinned people in images of socially desirable groups, like high-status workers or the wealthy. And then the overrepresentation of dark-skinned people in images of socially denigrated groups, including things like criminals or the poor. And so we really have this question of how can we improve the equity and diversity in model outputs? And we were inspired by this paper from last year, Bansal et al., suggesting this idea of ethical natural language interventions. And the idea is really to reword the prompt in such a way that we remind the model that we want it to behave ethically. So instead of asking for a photo of a CEO, we might ask for a photo of a CEO if all individuals can be a CEO, irrespective of skin color. And in this paper, they really found that it was this phrase, irrespective of skin color, that led to an effective improvement in representation in their outputs. So we really wanted to dig into this a little bit more. It's just a very small pilot study, but we looked at 3 pairs of stereotypes where one side of the stereotype is more associated with lighter skinned people and one side of the stereotype is more associated with dark skinned people. So a wealthy person versus a low income person, a person wearing a suit versus a person wearing a basketball jersey, and a lawyer versus a felon. And for each of these stereotypes, we had a baseline prompt. And so these images were all generated by Midjourney for the baseline prompt. Then we had our intervention prompt, which used this phrase, if all individuals can be, say, a lawyer, irrespective of skin color. And then we also had a simplified intervention where we just appended the phrase skin color to the end of the prompt, because we kind of had this hypothesis that that was the phrase that the language model was really latching onto. So we looked at 3 very commercially popular systems, Midjourney, DALL-E, and Stable Diffusion via Dream Studio. We generated 12 images for every prompt. We had 3 prompts for every stereotype, and we had 6 stereotypes. So we ended up with 216 images for each model. And then we had a manual annotation step for perceived skin color of the people in the output images. Now the results, I think, are easiest to explain with an example. So these images were all created with Stable Diffusion. If we ask for a photo portrait of a lawyer, we would get a bunch of pictures of white men. If we ask for a photo portrait of a lawyer, if all individuals can be a lawyer irrespective of skin color, then we do end up getting images of darker skinned people. On the other hand, if we ask for a photo portrait of a felon, we end up with a bunch of images of Black men. And then if we ask for a photo portrait of a felon, if all individuals can be a felon irrespective of skin color, we do not end up with a bunch of pictures of white men. We end up with even more images of darker skinned individuals. So the quantitative results are in the paper, but the take-home message is that to some extent or another, we see the same pattern for all of the stereotypes that we looked at and for all 3 systems. And the kind of intuition here is these text-to-image systems learn from image caption pairs. And a lot of previous work has shown that when the subject of an image possesses the kind of default or expected characteristic, then annotators don't bother to mention it in their caption. And so phrases like skin color are really only used when the skin color is not the default value, which in this case is white. So the system implicitly learns that skin color really means that it's dark skin color. And this is kind of our intuition of why the intervention works in one direction, but not the other. As a very quick sidebar, we did not explicitly look at gender bias in this work, but it is impossible to ignore. When we prompted for portraits of lawyers, we got overwhelmingly male images. So that will be a discussion for another day and another paper. But in conclusion, we observed this kind of overrepresentation of darker skinned people in images of felons, low-income people, and people wearing basketball jerseys, an underrepresentation of darker skinned people when we're talking about lawyers, wealthy people, and people wearing suits. And the intervention really only worked in one direction. So I think this is telling us there's a lot of work that is still to be done in terms of the data set, the data balancing and curation, how we train the models, and then also in terms of what we as users can do at inference time to generate more diverse outputs. So thank you. I'm happy to take questions now or grab me later or feel free to shoot me an email. Thanks.
Thank you. Okay.
Thank you for interesting paper. Now I'm just thinking about your study and then some of the other conversations that we've had today. So one of the issues, of course, is the data sets that are training these systems. And if you look at, I don't know if anybody's looked at internet research more generally, but there is a number of studies that show the internet is not a diverse place. When you look at, there are studies that have looked at images available on the internet, and it is primarily white people. It is actually primarily white men. And the percentage of people who are people of color or people who are intersectional in some way is much, much, much lower. And there have been, community projects actually focus specifically on interventions that are more based on how do we ensure there are more photos of, Black women scientists on the internet, because overwhelmingly what we see are not those images. So, I mean, there's different problem solves here, but I think, again, part of the problem solved to some of these issues is actually who's just out there on the internet to begin with, or how do we look at language on the internet? So there may be interventions in other kinds of ways. Sorry, this is more of a comment than a I'm realizing.
Go for it.
But I'm just wondering about, again, those sort of looking to other much older research, right? This is not new. Some of these problems are not new, right? We know that this is an ongoing problem in society as a whole, but in particular in research on the internet.
Thanks.
Hi, I was wondering what you mean by dark skin in your paper, because it kind of seems like you just mean not white. And I don't know if it's like maybe more prevalent in Canada to use darker skin, because different groups of people, you have different skin tones, and a lot of the examples you use were of Black people. So I was just wondering.
Yeah, so thank you for asking that question. We, in our annotation, we thought about a bunch of different ways to do this in a sensitive way. What we decided on, and this is following the work of Joy Bulamwini, probably mispronouncing that, that best practice is, rather than trying to classify people, I guess, as like, oh, this person is Black, this person is South Asian, this person is, East Asian, is to just annotate along a spectrum of like, this person has lighter skin, this person has darker skin. I have my one extra slide about the annotation. And so we really just ask people to annotate along the spectrum without saying necessarily, this person looks African or something like that. But the examples that I gave, I totally agree. Like for felon, for example, I would say that these people look Black, and this is just the output of the system. The system didn't tend to output, Asian people as felons, or even people that you would probably identify as mixed race, something like this. It's very dark-skinned men is what it did. So that's how we approached this problem, but I know it's a very sensitive topic, and I would love to chat more if people have some suggestions about better ways to approach that.
Thank you, Kathleen. Great, so let's give Kathleen a round of applause again. Oh. Our final talk today is online. So this one, we have a little special bit of introduction for this talk from Alison. So Alison, as you'll know, is one of the program co-chairs this year. For Alison, this is a bit of a special talk because it's very close to her heart, and it's with her dad. And her dad has been thinking about these ideas that we're about to see the talk for more than half a century. And the idea for this paper came as they travelled back to Edinburgh from the climate protests at COP in Glasgow in 2021. And it suddenly seemed clear to her that academics should be doing something about this. And I think I'm allowed to say this bit as well. Alison's dad, Arnold, will turn 95 on Monday, so might be our most elderly speaker of ICCC ever. So I'm going to hand over to our recorded talk, and then Alison, I think, is online for questions afterwards.
Hi, I'm Arnold Pearce, and I've been working on environmental issues since the late 60s, when it became clear that humans were causing great damage to the planet. Since then, I've worked with an NGO called Green Deserts, researching anti-desertification measures in a dry, degraded area of southeast Spain, and coordinating a series of field trials in Tanzania, Burkina Faso, and Morocco, in which we developed, tested, and promoted methods of producing locally adapted mycorrhizal inoculum to assist the re-establishment of indigenous trees. More recently, I've been involved in climate actions within the UK.
Hi, I'm Alison Pease. I'm increasingly involved in environmental work within my university, leading the Green Impact Award for computing and working on sustainability issues within my school, as well as participating in climate actions as an individual elsewhere. Dad and I have been working on these issues since I was a little kid, and we'd go around the neighbourhood collecting people's recycling. I've worked in CC for a few years now, and I'd like to bring thoughts on our environmental work to the community. Thank you for having us.
The recent IPCC report, the Intergovernmental Panel on Climate Change, warns that greenhouse gases are still increasing. They need to peak in the early 2020s and be followed by rapid and deep reductions in this decade. This means rapid and far-reaching transitions across all sectors. The report points out that feasible, effective alternatives to fossil fuels are already available, and that removing fossil fuel subsidies would reduce emissions and improve public finances and economic performance. These are the agreed conclusions of scientists all over the world. The report is a massive document carrying immense authority and warns that any further delay in concerted global action will miss a brief and rapidly closing window of opportunity to secure a livable and sustainable future for all.
So as the planetary emergency deepens, we need to reconsider the role of academics and universities and expand our conception of responsible research and how we contribute to the public good. Governments around the world are failing to respond to the IPCC report, so it's our duty to advocate for the planet. In a world increasingly in crisis, all academic communities should urgently be asking ourselves, what can we do? Firstly, as a research community, we need to make sure that we're not adding to the problem. This means monitoring and reducing our carbon footprint. We need to denormalise the idea that a massive carbon footprint is necessary or justified to conduct research. Let's look at practical alternatives and show that it can be done. We should rethink our conference model so that we don't require people to fly around the world in order to be active members of our community. This doesn't necessarily mean holding remote conferences. We all enjoy seeing each other. There are lots of alternative conference models which offer opportunities for new, green and sustainable academic practices. For instance, I like the idea of regional hubs which are virtually connected. We also need to think about the carbon impact of our computational infrastructure. Computing emissions already account for more than emissions from the airline industry, and they're set to rise to frightening levels. We need to engage with a vision of low carbon and sustainable computing, such as the frugal computing paradigm, and there are details of this in our paper. We're a relatively small and tightly knit community in CC, and you could argue that these actions would have very limited impact. However, I think we can use our size and makeup to our advantage. We're small enough to experiment with different conference models and interdisciplinary enough to have a potential influence across a wide range of disciplines and other conferences. The second thing we can do is to use our expertise in CC to help to solve the problem. Creative thinking will be essential in addressing climate change, so there are lots of opportunities for CC to contribute. We make suggestions for these in our paper. So our main message is that as a community we need to think about and act on this issue fast. We already have a CC task force set up. At the community meeting last year, people suggested using this task force for the climate issue, which is a great idea. I propose we use this to organise a workshop to discuss how we can lower our carbon footprint and contribute in other ways. If you'd like to be involved and you're not on the task force, then please email me at alisonpease@dundee.ac.uk, and my email address is on our paper in the proceedings. Other actions we can take include talking about it here at the conference to your colleagues at home and to your students, teaching it, incorporate it into your module and student inductions, and campaigning within your universities, or writing a letter to your democratic representative to ask them what they're doing about the IPCC report. Many thanks for listening, and we look forward to working with you all on this important topic.
Thank you, Alison and Arnold. Do we have both of you? We just have Alison today.
Just me. Hi.
Steve to Paolo first. Waving. Do you have a question? No? Any questions? I'm going to sneak in a little question and take advantage as chair. So in the paper that I just presented, we found that on the online conferences, the number of authors increased dramatically, and we saw some geographical patterns. But then we also saw that it was really, really hard for some people to engage in the conferences online. So you proposed this idea of hubs, regional hubs. Could you say a little bit more about how that might look?
Yeah, sure. So these are not my idea. These are, I've forgotten whose idea it is, but the reference is in the paper for it. These are where you co-locate workshops on computational creativity across the world, so that everybody can get to them just by traveling over land. And then you remotely connect so that you have the experience of the plenary group. So you could connect for keynote talks or maybe a panel or something. But at the same time, you have the opportunity to meet other people who are working in the field.
Thank you. And I'm going to pass you to Barbara.
Yeah. Hi, thanks for a nice presentation and also very important one. I agree with you that, I mean, here's kind of a, very kind of problematic question, or how we decide kind of how to find the balance, right? So we all like to meet at the conferences, and I think it's very meaningful to connect with colleagues and so on. But the question is always in numbers, right? So, and universities and academia, they demand more and more outputs, and this results in many papers. So a few, I don't know, maybe decades ago, publishing one paper was enough. Now, you know, some of my colleagues, they publish 30 papers a year. So how we, I mean, I think we have to push also, I think, back towards, you know.
Yeah, absolutely. I mean,
another is,
it's the system that we're working in that's kind of requiring us to fly a lot of the time. You know, a lot of people would rather, academics would rather fly a lot less, but because it's all tied into publication, and publication tends to be tied into attendance at conferences around the world, we sort of have to in order to either get a job or get promoted within the job. So yeah, it's about changing those systems and changing the ways that we can do it while keeping ourselves kind of conducting good quality global research. It's hard. So I guess that the purpose of this paper was just to start the conversation. I definitely don't have solutions on this, but it's something that we as a community, I think, should be talking about.
Thank you, Alison. There are more questions for you in the room, but I'm going to have to close the session, I'm afraid. So thank you for joining us.
Thanks very much for having me.
Alison again. Okay, we're moving into the coffee break now. I think Dan's got announcements.
Just a couple. Hello, everyone, and thanks, Alison. And also, Alison, who's, I guess, just disconnected, was one of our program chairs, so thank you to her for that, too. Have a great day, Alison. All right, we're moving into a coffee break and then demos and posters. The demos and poster spaces are all set up for you. Please set up your demos. What we're going to do in about a half hour is we're going to, rather than have you all come up to the stand and give your little 20-second spiel about your talk, Joao is going to be the cocktail barker, and he's going to go from stand to stand to stand and give you 20 seconds rather than having you all line up here. So the plan is get your demos and posters set up, and in about 25 minutes, we'll do quick introductions to everyone's poster. And he wants to say a little bit more.
Yeah, last year I was demo chair, and one thing that I learned was while people are presenting, please don't talk to each other, okay? Save that for when everyone has finished. Otherwise, it will be hectic. No one will hear anything. So just find a nice spot, hear what people have to say, and then after everyone is done presenting, go talk, okay? Enjoy the coffee break, and then demos and posters.
And just one last announcement, the only other thing on the schedule for today is after the demos and posters, we have the artists panel going on at the stage. So stay tuned for that too. That's at 5 o'clock. And the moderator for that is Dan Ventura. No more streaming for the rest of